Okay, so in this question, this is what's known as a rate of change question. And it specifically relates to the rate of change of volume. So this is a rate of change of volume. So this really is where we're using calculus to solve, like, let's say, like a real world kind of problem. So if we have, so what it's saying is water is collected in a water tank. The volume V, which is in cubic meters, and it's important to note the units as well. So that's going to be meters cubed of water in the tank after time, which is in minutes, is given by this expression here, or this function. So V, so this V represents the volume, is equal to 3 times the time squared plus 4 times time plus 2. So what we can see here is that we have an expression here that we can use calculus on. So what it's asking you to do is to find the rate of change. So if we think about the rate of change, so that's how the volume is changing in respect to time, or another word for that is the slope, or the first derivative of the volume with respect to time when the time is when it's 2 minutes. Okay, so basically what this expression here, this function, it describes the filling of a water tank. This represents volume and this represents time. Now, so if this represents the volume, so what you can do is that you can pick any particular time and you can plug it into this expression, and what that will give you, it'll give you the volume at that particular time. Now, what it's actually asking for is the rate of change of volume with respect to time. So you're getting the first derivative of this guy here. So remember, V is equal to 3 times t to be squared plus 4t plus 2. What we're trying to get is, we're trying to get dv dt. So dv over dt. So this is the same thing as, like, instead of dy dx, we're just replacing the y with volume and the dx with time, which is t. So we do exactly the same thing that we've learned. So we get the first derivative of this. So remember, we take the power, we multiply it by the coefficient, and then we drop the power by 1. So what does that so 3t to the power of 2, that becomes 2 by 3 is 6t, and then we minus 1 from the power, so that just leaves us with 6t. Plus, remember, so this is 4t and this is to the power of 1. Remember, it means so it's 1 by 4, which is just going to be 4. And then we drop this, so this will become t to the power of 0, which just returns to 0. So that just becomes, so 4t differentiates to just 4. And then this here, this just drops off. So the first derivative of this function, dv dt, is equal to 6 times t plus 4. Now, what we can do is we can use this. So basically what this does is it gives us dv dt, or it gives us the rate of change of volume with respect to time. So that's what we have here. So we can take any particular time and we can look at the rate of change at that particular time. So all we have to do is we just put in, we can just substitute this value here into our expression, or into our function. So when t is equal to 2, what we do then is we just substitute this value in here into this. So that's going to become 6 times 2 plus 4. And then we just work this out. So 6 times 2 is 12 plus 4. And that's going to be equal to 16. So this is 16, so it's the rate of change of volume with respect to time. So it's 16, the volume is in meters cubed. So it's 16 meters cubed, 16 meters cubed per minute. So what we can see that at time after 2 minutes, the rate of change of the volume is 16 cubic meters per minute. So water is collected in a water tank. The volume V, which is in cubic meters of the water in the tank after 2 minutes, is given by this expression. So find the rate of change of volume with respect to time when the time is 2 minutes. So we take our expression, we differentiate it, we get this expression which tells us the slope at any particular time point. We're interested in at the 2 minute time point, so we substitute that value into this expression, we work this out, and that tells us that at time t, at time where time is 2 minutes, the rate of change of the volume is 16 cubic meters per minute.